Okay, guys, a few of you requested some different types of problems that you wanted to hear me talk through for the review tonight. So here's what I have. I've got a proportion, which was number 19. I've got one of those problems where we're trying to solve for y and actually write it in slope-intercept form, which was number 27. Number 30 was one of those formulas where we're solving for a specific variable. And then number 32 was a word problem. So that's what I'm going to be doing. Hopefully that'll work out for you. Okay, so number 19, we've got a proportion. Remember, to solve a proportion, we just cross multiply. It doesn't matter what value you start with, but we're going to make the x through the proportion to do the cross multiplying. So if I start with the negative 2, I know negative 2 is going to multiply with x minus 5 equals, and then the 4 multiplies with the x plus 3. If you want to go ahead and distribute as you do that, that's fine. Just please make sure you remember to distribute. So negative 2x plus 10 now equals 4x plus 12. Okay, and then we just have an equation with variables on both sides to solve. So I'm going to move the 2x's over and add them to the right side. So 10 equals 6x plus 12. Okay, subtract the 12. So negative 2 equals 6x. And then divide by 6. Please do not go to a decimal. Let's use that fraction and just reduce it. So negative 2/6 is the same as negative 1/3. So that would be my value of x. Okay? Okay, number 27, we're going to slope-intercept form. So you have to know what slope-intercept form is. Slope-intercept form, remember, means solve for y, but not only solve for y, get it in the correct order on the other side. So we're going to do y equals mx plus b. So you want the x's to appear in the equation directly after the equals, and then a constant at the end. Okay? So I want to get y by itself. That means I'm going to move the x's. So I move 7x's by subtracting them from both sides. Okay? So 3y equals. Now if I wrote 15 minus 7x, then I don't have the x's directly after the equals. I'm not going to slope-intercept form. So I'm going to rearrange that, put the negative 7x's in front, and then the plus 15. Then the only thing left with the y is a 3, so I'll divide the 3. Okay, cancels that 3. So y equals, so I have negative 7/3. Again, do not go to a decimal. Leave the fraction. Just reduce it if you can. This one can't. So negative 7/3 x, and then the 15 over 3 becomes a 5. And there we have our slope-intercept form. Okay, now number 30, we're solving for b. Right now on the same side as the b is a 1/2 and an h, so both of those two terms need to be moved. Remember with a fraction, I don't want to divide by a 1/2 because that gets messy. So instead of dividing by a fraction, we get to flip it over and multiply it. 1/2 flipped over is just 2, so I'm going to multiply both sides by 2. So the 2 and the 1/2 cancel. I have 2a equals bh. Since I'm solving for b, now I need to move the h. The b and the h are being multiplied, so I'm going to divide. Okay, cancels out the h, and you look, you've got b all by itself. Remember I said these aren't going to be pretty. You're not going to get x equals 2 or anything like we're used to. You're going to have a new formula that's just been rearranged. Okay? All right, last one, 32, word problem. We've got Sam and Carly heading to the mall. Sam left at 3 o'clock, rode her bike 7 miles an hour. Carly didn't leave till 4 and rode her bike at 9 miles an hour. What time will Carly catch up with Sam? Because we've got rates and times and distances, I'm going to set up my rate, time, distance table. So I have Sam and Carly. I need a rate, a time, and a distance. Okay, so Sam's rate was 7 miles per hour. Remember, time means how long it takes. We don't know how long Carly will be on her bike, so I'm going to put an x. And to get the distance value, we multiply the rate times the time. So 7 times x tells me a distance of 7x. Okay? Carly rode her bike 9 miles an hour. And for her time, we don't know it either. But if Sam is on her bike for x hours, Carly left an hour later. So she's going to be on her bike fewer hours. So Carly's time is going to be whatever Sam's is, minus 1. Okay, she's on her bike fewer hours because she left later, so subtract off that difference of time. And then her distance is again 9 times x minus 1. Multiply those together. Now when you're doing a rate time distance problem, you really only have two options. Either we've got a first distance plus a second distance to equal a total. Okay, so that would be something like one person's going north, one person's going south. How long is it going to take till they're 200 miles apart? We have a total, so I would add their distances. Or we have a situation in which the two distances are the same. And that would be more of this situation. I know Carly and Sam are going to be in the same place because Carly is catching up. So I'm going to set their distances equal to create my equation. So 7x equals 9x minus 1. Okay, so I'm going to distribute. 7x equals 9x minus 9. Normally I say to move the smaller x's, but I think in this case that'll involve more steps. I'm going to go ahead and subtract my 9x's. Okay, so 7x minus 9x makes negative 2x. I've got a negative 9 left. And then when I divide by negative 2, that tells me x equals 4.5. Now be careful because make sure you've answered the question. The question doesn't say how long will it take. It says what time will Carly catch up with Sam. So 4.5 is not an answer. If Sam left her house at 3 o'clock and it takes her x hours, we now know that x equals 4.5. So 3 o'clock plus 4.5 hours means that they're going to be in the same place, ooh, ugly 7, at 7:30. Hopefully p.m. because I hope they're not riding their bikes around New York City at 3 and 4 o'clock in the morning. But anyway, make sure you read the question and answer what the question is actually asking you to do for those. Hope that helps.